Let's complete this section by solving the remaining exercises. In these exercises, we have to find only the general solutions. And this fifth one is cos 4x equals cos 2x. We have to solve this equation. Solution, we have cos 4x equals cos 2x if and only if cos 4x minus cos 2x equals 0. Now we need the formula for cos A minus cos B, and that formula is this: for any two real numbers A and B, cos A minus cos B equals minus 2 sin A plus B over 2 times sin A minus B over 2. If you are preparing for some kind of examination, obviously these things, you will just simply remember these things. You would have written these things down so many times that you remember them by heart. But say you forget. Suddenly say you forget which one is which one, because there are 4, right? What will you do? That is why blindly memorizing something is really not a good idea. In that case, you can simply do this. You see, what do you want from these formulas, whether it's cos A plus cos B or cos A minus cos B or the two involving sign? Ultimately, in every formula, you have A plus B over 2 and A minus B over 2. These things are always there in all the 4 formulas. Now note that we can give these things some names. Okay, let me call this, say, S and this D. S represents sum, D represents difference. You can give them some other names also. Now, what do we get if we add S and D? If we add S and D, that means we are adding these two numbers. Obviously, the B terms get cancelled and we have twice of A over 2, so we get A. Similarly, if you subtract D from S, that is just this. Now, however, the A terms get cancelled and we ultimately get B. So, if we now write, say I have forgotten this formula, I can't quite remember what it had, so I don't know this. So, what do I now write? In place of A, I write S plus D, and in place of B, I write S minus D. Alright. Now I apply the ordinary cosine angle sum formula. That, however, we have to remember. We do have to remember at least something. Cos S, cos D. Recall that whenever we have plus, the formula tells us to write minus. Sin S, sin D. As opposed to this, whenever we have minus, then the formula has both plus terms. But there already is a minus in front, so it will be cos S minus cos S cos D minus sin S sin D. So these two terms cancel each other, and here we have 2 times the same thing, that is minus 2 sine S sine D, and that's just it. In place of S you write this, and in place of D you write that, and that is why there is a minus and there is a 2. And you note one more thing, that because ultimately the way we derive this formula involves expanding cosines of angle sums, that is why cos and sin terms appear. The cos's get cancelled and we are left with sine, and that is why in a formula involving cosines, we have the same type of term. Either we have cos or we have sin. And this way, it now becomes easier to not just remember, but you also understand why it looks like this. And do you see that it really doesn't take a long time to derive this? If at all you are in a position where you have forgotten the formula, you can quickly do this. That's it. So now we apply it here. Minus 2 sine 4x plus 2x over 2 times sine 4x minus 2x over 2 equals 0. Another thing to keep in mind is you write the full thing, no matter how tempting it is, how tempting it looks to simply just not write minus 2 here, because anyway you are going to cancel minus 2. There is 0 on the right hand side, but you write the entire thing. It shows that you know what you are writing. Okay, now instead of straight away cancelling 2, let us do the simplification first. What is this? 4 plus 2 is 6, 6 over 2 is 3. Minus 2 sine 3x times 4 minus 2 is 2, 2 over 2 is 1. Sine x is equal to 0. At the next step, you can get rid of minus 2. Sine 3x times sine x is equal to 0. If and only if. Now the product of these two real numbers is 0. So at least one of them is 0, or maybe both are 0. So sine 3x is 0, or sin x is 0. Again, I am repeating, these things actually are important. Here or includes and. It doesn't mean that either this happens or this happens and they cannot happen simultaneously. No, they can. This is inclusive or. And we know precisely when sin 3x is 0, namely when 3x is n pi for some integer n, or, and sin x of course is 0 if and only if x itself is n pi for some integer n. Ideally you should write some other symbol here, because this is another equation. No? I mean, right now at this stage we are looking at two equations. Either this happens or this happens. They may simultaneously happen, but in general we just treat them as different equations. From this equation you are going to get some x values, from that equation you are going to get some other x values. There may be some common values. So ideally you should write something else here, say m. But ultimately that does not matter. You can simply just write n. N means an integer. If and only if x is n pi over 3, or x is n pi for some n. Instead of writing n and m here, simply writing n in both the equations, we do not lose anything. We don't lose generality. So this is the solution. These are precisely the x values for which this equation is true. This is the general solution. Then the next one, this one involves 3 terms: cos 3x plus cos x minus cos 2x equals 0. Okay. Remember, I told you something about such a situation. You have to figure out beforehand, before applying any such formula of cos c plus cos b, something like that, you have to figure out that ultimately whatever the formula is going to give you, if you are lucky means that's how these questions are set up, that whatever you are going to get from that formula, the other term which you are not involving in that formula also is that same thing. So what here we are going to do is we are going to apply cos a plus cos b formula to the first 2 terms. Let us, before applying, let us just think of what we are going to get. And by that I mean, of course, we are going to get 3x plus x divided by 2 and also 3x minus x divided by 2. We are going to get these 2 things. Now this is what 4x over 2x, and this is 2x over 2x. So the term you are not involving also has 2x. So it makes sense to take these 2 and apply the formula. And that's what we are going to do. Cos 3x plus cos x minus cos 2x equals 0. Now unlike cos a minus cos b, in cos a plus cos b you have cosine cosine. There you had sine sine, but here you have cosine cosine. 2 cos 3x plus x over 2 times cos 3x minus x over 2. Again, if you do not remember this, you can go through a similar calculation and quickly verify that this really is the formula. Minus cos 2x equals 0. Okay, so now what does simplification give us? This is going to be cos 2x cos x minus cos 2x equals 0. And the advantage is that we can now take cos 2x common out, and that will leave us with 2 cos x minus 1. So now we can proceed as usual. So this is equivalent to having cos 2x 0 or 2 cos x minus 1 0. Let me just keep this as it is for a moment. Cos 2x equals 0, or if you manipulate this second equation, you are going to get this. Now in order to solve this, you have to express this as a cosine. Cosine of 60 degrees is 1 over 2, or in radians that is pi over 3, cos pi over 3. And now we write the general solutions to each of these equations. The first one has the general solution. So what type of real numbers have cosines equal to 0? Odd multiples of pi over 2. Odd, so 2n plus 1 times pi over 2, odd. For this one you have to apply the general formula, that is x equals 2n pi plus or minus pi over 3, and now you can write where n is an integer. So one more line gives you this. So x needs to be an odd multiple of pi over 4, or x needs to be a number of this form, where n is an integer. So these are precisely the real numbers for which this equation will be true. I say precisely because for each of these real numbers this equation is true, and we do not have any other real number outside of this list for which also this equation is true. Okay, that we do not have. We have all the solutions here. Which is ensured by this double implication. Okay, now leaving signs and there is one more of this type. The seventh one. This one is sin 2x plus cos x equals 0. After that, we will see other trigonometric functions. Sin 2x plus cos x equals 0. Now you have to apply the double angle formula here. 2 sin x cos x plus cos x is equal to 0. Two sin x plus 1 is equal to 0. Admittedly, actually you really have to remember all the things by heart if you want to complete a solution in a reasonable time. Otherwise also you can do, but it will take a long time, and when you are writing an exam, that's not an option. So it's better to be prepared. So either cos x is 0 or 2 sin x plus 1 is 0. Or sin x is minus 1 over 2. Now here we have a negative value, and no standard x will give you a negative sign value. So you have to figure out which angle you can use here, for which again you recall the actual definition of sine. You have your unit circle centered at the origin of your coordinate system, and forget the minus sign for a moment. Then you just have 1 over 2. Which angle has its sine equal to 1 over 2? 30 degree or pi over 6 radian which is here somewhere. Okay, this much. But we want negative. Even if you somehow think of an angle whose terminal ray lies in the second quadrant, then also your sign is not negative, because sign is the y coordinate of these points of intersection of the terminal ray with the circle. And if your terminal ray is like this or like this, all the y coordinates lie above the x-axis, so they are positive, so sign is positive. You have to go below the x-axis, for which you have to be either in the third quadrant or in the fourth quadrant. So we want third quadrant. Okay, instead of straight away going to the fourth quadrant, let's just think of third quadrant. What did we say just now? We know that sine pi over 6 is 1 over 2. Pi over 6 is here. Okay, so to take it to the third quadrant, what will you normally do? You will add pi to it. That is, you, instead of simply taking pi over 6, you take sine of pi plus pi over 6. Now, if you expand this using the sine angle sum formula, what are you going to get? Sine pi cos pi over 6 plus cos pi sine pi over 6. Sine pi is 0, we already know that, so this term vanishes. Cos pi is minus 1, so that way you get minus sine pi over 6, which is minus 1 over 2. That means this is one of the angles that you can take here, and this is 7 pi over 6. So now you can continue and write one more step. This equals sine 7 pi over 6, and now you can continue your argument. Cos x equals 0 if and only if we know, of course, when x is precisely some odd multiple of pi over 2, and sin x equals sin something if and only if x equals n pi plus, recall the general solution, minus 1 to the power n times that angle, 7 pi over 6, where n is an integer. So this is the general solution. This will be your rough work. If you want, you can show this alongside the solution in the margin. And actually, if you show this type of things now, whoever is going to check your exam paper, they will know that, okay, the candidate knows what he is doing. It just shows that you haven't copied from somewhere else. Yeah, now we go to some other trigonometric functions. Number 8. Secant square 2x equals 1 minus tan 2x. We have secant square 2x equals 1 minus tan 2x. Now secant square 2x is 1 plus tan square 2x, which is equal to 1 minus tan 2x. You may actually forget this formula also, that secant square theta is 1 plus tan square theta. You may start memorizing these formulas like some kind of mantra. Secant square theta equals 1 plus tan square theta, secant square theta equals 1 minus tan square theta. Suddenly plus becomes minus and you just end up reading that 10 or 20 times with minus, and that becomes your formula, which is wrong. That is why whatever you do, even if you memorize, always remember where these things are coming from. Always remember the root. You at least know this thing, no? Sine squared theta, it's very difficult to forget this one at least. Right? From this, how can you get tan and secant? You divide by cos square. If you divide this by cos square, then you get this. Dividing this by cos square, you get 1 and this. So that way you get tan squared theta plus 1 equal to secant squared theta. So in place of secant squared 2x, we have written 1 plus tan squared 2x. So 1 gets cancelled from both sides, and if you add tan 2x to both sides, you get tan squared 2x plus tan 2x equals 0. Now it has become a simple matter, because you can take tan 2x common out, and the other factor is tan 2x plus 1, sorry. This equals 0. So either tan 2x equals 0 or tan 2x plus 1 equals 0. So this means, let us just keep this one as it is, and from here we are going to get a negative value again. Tan 2x equals minus 1. Alright. Again, you think of a way or an angle that will give you this value. I want to show you the full process. Okay. This type of things, if you do it enough number of times, it will quickly just suddenly come to you. But still, we need to go through the process, entire process, for at least 1 or 2 times for the first time. Forget the minus sign, you have 1. Which angle has its tangent equal to 1? 45 degree, or pi over 4 radian. Okay, which is 1/2 of a right angle. Now, is tan negative? Of course, nothing is negative in the first quadrant. What about the second quadrant? Keep in mind that tan is sine divided by cos. In the second, if the terminal ray of your angle lies in the second quadrant, then it will intersect that unit circle here somewhere. What type of sign do we have for the x coordinate of this point? Minus sign, because it lies to the left of the y-axis. Y coordinate, however, because the point lies above the x-axis, is positive. Positive divided by negative is negative. So in the second quadrant itself, tan is negative. And the angle we are getting is pi over 4. So for a second quadrant angle, you can try pi minus pi over 4. Is it really going to give you minus 1? Let's see. You can apply your usual tan A minus B formula here. There is no problem, because neither this angle nor this angle is an odd multiple of pi over 2. So we can apply the formula here. Tan pi minus tan pi over 4 divided by 1 plus tan pi over 4. Tan pi is 0. So this term vanishes, that means the denominator is 1, which is also as good as having nothing there. Tan pi is 0, so minus tan pi over 4, yes, that is minus 1. So this is one of the angles that we can consider. And if you simplify this, it becomes 3 pi over 4, right? So now we are ready to write the general solution. And the general solution, when does tan of something becomes 0? Precisely when sine becomes 0, because cos is in the denominator, it has nothing to do with being 0, making anything 0. It just has to be non-zero. And that happens when 2x is of the form n pi. Or, but for the second equation, you have to write the general solution for the tan equation, tan x equal to tan alpha, that thing, which is 2x equal to n pi plus the angle, where n is an integer. And one more step. So x is either of the form n pi over 2 or x is of the form n pi over 2 plus 3 pi over 8, where n is an integer. So this is the general solution. It has all the solutions of our equation. Now before I wrap this thing off totally, do you see one thing that many times when we are not, we do not really know about these things much. We used to do this a lot in school. You encounter an equation like this, no? Where you can take a term common out. What you do immediately, if you have 0 on the other side, you just cancel it. But see, cancelling really means what? Dividing. You can divide by 0 provided you know that tan 2x is itself non-zero. You can only divide by a non-zero real number. That is why we keep two possibilities. If tan 2x is 0, fine, we are going to want to know what x is. Otherwise, when tan 2x is not equal to 0, then you can cancel from both sides and have this. But if you simply cancel tan 2x, then you are losing these solutions. And finally, here is this last one, 9 sin x plus sin 3x plus sin 5x equal to 0. Here also one can go through one such similar process where you first decide which ones you want to use and which you want to keep. So you can quickly figure it out that it's beneficial to consider sin 5x and sin x together, and we just keep this one separately. And accordingly, in the beginning itself, we write the equation like that. Plus sin x plus sin 3x equal to 0. For sin a plus sin b, both sin and cos terms are there. Because there is plus, sin gets preference, it comes first. That's one way of remembering these formulas. So we get 2 sin 5x plus x divided by 2 times cos 5x minus x divided by 2. plus sine 3x equals 0. Alright, so that after a little simplification gives us what? 5x plus x is 6x, divided by 2 is 3x, and we have another 3x here. In fact, that's why we did this. So 2 sine 3x, and what about this 4 divided by 2 is 2 cos 2x plus sine 3x equals 0. So sine 3x times 2 cos 2x plus 1 equals 0. So either sine 3x is 0 or 2 cos 2x plus 1 is 0. Again, we are going to have a negative value, or cos 2x equals minus 1 over 2. And again, cosine is negative in the second quadrant because on this side. And which angle has its cosine equal to 1 over 2? 60 degree, or pi over 3 radian. So pi minus pi over 3. You can quickly see if it is right. Cos pi over 3 plus, because it's the expansion of cosine. When you have minus, you have plus. Plus, I am not even going to write sin pi over 3. Sin pi is 0. So this term anyway is 0, and cos pi is minus 1. So you get minus cos pi over 2, which is minus 1 over 2. So correct. And what is the angle? This is 2 pi over 3. That means this is cos 2 pi over 3. Now we can write the general, let me write it on this side, general solution for both the parts of our entire equation. So 3x should be of the form n pi, or from that one, again cos x equal to cos alpha, so 2x is 2n pi plus or minus 2 pi over 3. Do not forget to mention this, okay, that n is an integer. One more step gives us, or x equals n pi plus or minus pi over 3, where n is an integer, and that's it. There still are some more things in this chapter, namely the miscellaneous examples and exercises. That also we have to do. And these miscellaneous ones are slightly more, I won't say challenging, but they require us to think a little bit more. Same type of problems, but we have to think a little bit more to solve them. So we will see them in the next trigonometry video. And our next upload is this coming Friday, where we go back to calculus. So that's just it for tonight, folks. So see you on Friday. Until then, this is me, Lucifer, from a mathematical group. Have a nice night.